Hello everyone. Previously we had discussed on the heap sort algorithm, right? So today we'll be discussing on the counting sort. So yeah, today we'll be discussing on the counting sort algorithm, right? So let's start with the definition part here. So counting sort is a non-comparison based sorting algorithm. Again, it is not a comparison based algorithm. So it is a non-comparison based sorting algorithm that sorts the integers by counting the number of occurrences of each unique value, right? So this is very important. It is non-comparison based sorting algorithm. Just keep this in mind, that sorts the integers by counting the number of occurrences of each value, right? So it'll sort this one integers by counting the number of occurrences of each unique value, right? So it works efficiently when the range of numbers, this one max minus min, right? So max min is not significantly larger than the number of elements, right? So max minus min is not significantly larger than the number of elements, right? So this is fine. Now let's get into the explanation part. Just listen to this. Exactly the same thing will be implementing in the form of algorithm or the code, right? So counting sort counts how many times each number appears in the array, basically, right? So counting sort, what it does, it counts how many times each number appears in the array. So second one is it stores these counts in the separate array, nothing but count of this one array, empty array, whatever we have given here, right? So it then builds the sorted output by placing the elements according to the counts, right? So these three importance, right? These three these three are the important points. Basically, counting sort, what it does, it counts how many times each number appears in the array, right? So suppose we have 1 1 2 7 6. So 1 is repeated twice, this one 2 is repeated once, 1 2 3 7 6, right? So 2 is repeated once, 3 is repeated once, 7 is repeated once, 6 is repeated once, just for the sake of this one understanding, right? So this one, it stores these counts in the separate array count. So basically we have got 1 twice, 3 2 3 7 6 once, right? So this one count will be stored in the separate array. Then it builds the sorted output by placing the elements according to their counts, right? So then it builds the sorted output by placing the elements according to their counts, right? So one is placed, one is this one comes twice, 1 1, then 2 3, this one 6, after sorting, then 7, right? So simple, right? So that will be the output. So this is stable. It preserves the order of equal elements and works on big of n plus k time, right? So this is the time complexity basically. So big of n plus k will be our time complexity, where n is nothing but the number of elements and k is nothing but the range of input values, right? So this is simple. Now let's try to implement the same thing in the form of code or the algorithm. Let's start writing the algorithm, right? So this is fine. Let me go with the function name. I'll just go with counting, this one, counting sort. So this is fine. Now let me pass the array. Yeah. So within this function, let's find the maximum element, right? When I say maximum element, that is needed to size the count array, meaning, so max value, let's assign this one to the max of 3, right? So this one will be max underscore value, so that is equivalent to max of this one array. This is fine. Now let's go with the step 2. So we have to create and initialize the count array of size max underscore value plus 1, right? So this will be count, yep, count equals this one 0 and 2, or this one max value, this is fine, plus 1, right? So this is fine. Now let's do one more thing. Let's go with the step 3. We have to count each element's frequency here, meaning, so let's go with the iteration part here. So this will be for num in the array. So this is fine. So within the for loop, so let's increment its count. So I'll just go with count num, this one equals count of num plus 1, right? So we are just incrementing the, or we are just counting each element's frequency here accordingly with the this one explanation that we went with, right? So now after counting the each element's frequency, we have to build the sorted output using the count array, right? So how can we write that in the form of code? So this one will be sorted underscore array. So I'll just go with the sorted array here in simple terms of the variable name. So I'll just assign this one to the empty array. So let's go with the for loop. So this one for I in range, point the iteration part, right? So for not in range, so this is for I in range, right? For I in range, this one length of count. This is also fine. Now within the for loop, what we'll be doing, let's go with one more for loop, meaning we have to repeat the number of this one. We have to repeat the number count of I times, right? So this will be for score range. Let me go with count of I. So this one will be count of I, right? So this is fine. Now within this for loop, let's add this one to the sorted array, meaning I'll just go with the let me go with sorted array. So we have to append the I to the sorted array, right? So let's go with dot append I. So we're just adding this one to the sorted array. Finally, we are left with only one step, meaning we have to return the sorted array, right? So this one return sorted array. This is fine. We are done with the this one. This is it, right? So we exactly this one articulated the same thing that we went with the explanation part that we discussed on the explanation part, right? So this we exactly articulated in the form of code, right? So we are done with the algorithm part. Let's go with the example usage of the example this one. First, let's go with the example input. I'll just go with nums. Let me go with some random numbers here, 1, 2, 2. So this one is fine. 8, 3. 3. Let me give one more time. So let me give 1 here at the end. So this is fine. Now let's call the function. Let me go with the result variable and let me call the function counting sort here. This is fine. So we have to pass the num side. Finally, let's print something for the what do we call interactive purpose. So I'll just go with, we have to get the sorted array, right? So the sorted array here, this is fine. So let me pass the result here, this one. Yep. We are printing the sorted result. This is fine, man. So this one has to be into multiplication operator. This is fine. We are done with the we are done with the algorithmic part, also the example usage, right? So now let me explain whatever I have written very quickly. So this one, max value equals max of array within the function. So this one basically this finds the largest number in the array to know how big our count array should be, right? So this is fine, I believe. Next, count equals 0, this one, line number 9, 10, 0 into max value plus 1, whatever I have written. So we are creating a list of zeros to keep count of each numbers from 0 to maximum value, right? So this is fine, I believe. Now let's move on with the iteration part here, line number 21. So for now, for num in array, so this one we are going with count of num equals count of num plus 1, right? So this one, line number 21 and 22. So we are looping through the original array and we are increasing the count at the index that is equivalent to the number. This is fine. Now let's move on with the next part, that is nothing but this one, sorted array equals this one, empty array I have given, right? So this creates an empty list to store the sorted result. This is also fine. Now let's move on with the fifth this one part. So for I in range, whatever I have given this one length of count, so we are going with the iteration, right? So here this loops through all the possible numbers and we are going with one more iteration here within the same for loop, right? So this one basically for each number this appends it to the sorted array as many times as it appears, right? So finally we are going with the return sorted array. So we are just returning the this one sorted array, or this returns the sorted array basically. So finally what we are doing, we are calling the counting sort function here of nums and we are printing the sorted result here, right? So we are done with the counting sort algo. So this is it, right? So now let's do one thing. Let's run the code. So we have to get the first this one. What is the output that we need to get here is sorted this one, right? So 1 1 2 2 3 3 and 8, right? So this is the 3 3 4 I have not mentioned here 4, right? So 1 1 2 2 3 3 and 8 we have to get, right? So let's see what output we get here. So before running the code, let me copy the file name here. We press Ctrl J. So this one will be Python Ctrl V file name dot py. So see here the output that we are getting here is 1 1 2 2 3 3 8. So we are getting the absolute correct output, right? So we are getting the desired output. Basically the algorithm this one counts one this one, what do we call 1 twice here, right? So 1 1 we have went with, right? So algorithm counts 1 twice, 2 also twice, 3 also twice, and finally 8 only once. 8 only ones, right? So first we'll be putting 1 within the array, second we'll be putting this one 2 number of ones in the array, then we'll be putting number of 2's in the array, nothing but first we'll go with 1 1, see here in this way. So first we'll be going with 1 comma 1, then we'll be going with filling with 2 comma 2, then we'll be going with 3 comma 3, then we'll be going with 8 finally, right? So this is the approach that we'll be going with basically, right? So let me delete this one. This is fine. Then yeah, 1 1 followed by 2 2, then followed by 3 3, and then 8. So this is fine. Now we are done with the this one, counting sort. So this is it for the counting sort algorithm, right? So let me summarize whatever we have learned so far. Just try to remember these 3 or 4 points, right? So this is very important. So counting sort is best for the sorting integers when the range is small. Just remember this one. This is very important. Counting sort is best only when sorting integers for the sorting integers when the range is very small, right? So this you have to keep in mind. Time complexity, we have already discussed this one. Time complexity is big of n plus k, and space complexity is big of k. So, and also we have discussed this point as well. Just try to remember this one. It is not comparison based algorithm, right? So this is not the comparison based sorting algorithm, right? So and also it is very stable, but it is very stable. So this is not comparison based, but it is very stable, right? So we have to avoid this algorithm when the range k is much larger than the number of elements, nothing but n, right? So we have to avoid this algorithm when the range k is much larger than the number of elements n, right? So just remember these points, man, right? So we are done with the counting sort. We are left with only one one algorithm in the sorting algorithms part, that is nothing but the radix sort or the bucket sort, right? So tomorrow we'll be discussing on the radix sort or the bucket sort algorithm, and we'll finish it off tomorrow, right? The sorting algorithms, this one, what sorting algorithms playlist, right? So after sorting algorithms, from day after tomorrow, we'll be discussing on the searching algorithms. We'll be starting with the binary search basically, right? So tomorrow we'll be discussing on the radix sort or the bucket sort. For now, this is it. Thanks for watching, guys.